Hello everyone, good afternoon. Thank you so much for attending this webinar. My name is Prasad Sonawane, Field Application Engineer from VVDN Technology. Today we will discuss about ActiveRoute feature in Altium Designer for advanced routing. What is ActiveRoute? What are the different features related to ActiveRoute in Altium Designer? So for upcoming webinars, please do visit our website www.vvdntools.com/event for upcoming webinars and upcoming events. Today's agenda is what is ActiveRoute, then benefits and capabilities of ActiveRoutes. What is the difference between AutoRoute and ActiveRoute? As we know, AutoRoute is the already option available in Altium. But what is the difference between AutoRoute and ActiveRoute? Then what is guided routing, non-guided routing, difference between guided and non-guided routing. Then next route guide with ActiveRoute. What is a route guide included in ActiveRoute? Some important features like Fanout, Retrace, and live demonstration. So what is ActiveRoute? Actually, one of the most time-consuming phases of board design is routing the nets. And routing should follow constraints such as width, via sizes, clearance, and other design rules. So in order to meet these expectations, Altium provides automated routing in the form of ActiveRoute. ActiveRoute is an automated interactive routing technology that delivers efficient multi-net routing, which is applied to the specific nets or connections selected by the designer. ActiveRoute also allows the designer to interactively define a route path or a route guide, which the new routes will follow. So as you see in the image, route guide is shown. These are route guided, these are non-guided. So benefits and capabilities of ActiveRoutes. The key ActiveRoute feature that makes this approach significantly better than a combination of regular interactive routing and auto routing includes high-speed routing, approximate 1 route per second. Then ActiveRoute obeys design rules for width, clearance, layers, topology, and rooms by net and net classes. Then ActiveRoutes on a multiple layer simultaneously. It routes on multiple layers simultaneously and distribute the routes across those layers. Automatic optimization of the escape route out of pin via arrays. Route guide allows designer to place route directly. What is the difference between AutoRoute and ActiveRoute? Basically, ActiveRoute is not an auto router. It is a guided interactive router which focus on clean, high quality routing of a set of selected nets. ActiveRoute is like choose the net you want to route, then enable the layer onto which you want to route, and think about the path they should follow and route them. Basically, ActiveRoute is like this. So AutoRouter sometimes fail to correctly consider the suitable design rules. If you set some design rules, so sometimes AutoRoute fail to recognize that rules, and AutoRoute is taking a longer than usual time to route the PCB and clean up in the AutoRoute can be a such long or difficult process, which is not taking more time in ActiveRoute. Guided versus non-guided routing. So guided routing is nothing but you can give the path to routing. You can guide the route. You can guide the routing. Guided routing indicating that the set of connections must flow through the guide. Move the cursor to a suitable start location. You can select start and end location for guided routing, and either end of the path you want to define. That means you can define the path in the guided routing, and non-guided routing is like it simply taking a shortest possible path for routing. in non-guided routing. Route guide with ActiveRoute. As I said, route guide is nothing but you can guide for routing. The main purpose of using a route guide is to allow the user to control the direction of routing flow. You can control routing flow direction. ActiveRoute will generally follow the most direct and shortest path to completion. However, there may be situation in which the designer would prefer the route to flow in a very specific direction. As shown in the image, green colored path is designed by designer. As I shown in the image, green colored path is designed by designer, which is nothing but route guide. A route guide can be used to achieve designer's overall routing plan. Some important features in the Altium are Fanout, Retrace. What is meant by Fanout? Fanout is a technique where short traces and wires are used to connect inner rows of pins on high pin count ICs. If you are doing Fanout for multiple pin ICs, Fanout can also route traces to a device with very close space pin. This makes routing connections much easier by using Fanout. Retrace. Retrace work exactly as its name implies, running along the selected route, updating them to the current specification because it does this on individual net or pair level. It will attempt to maintain clearance but is not able to push surrounding route if more room is required. In this situation, the rule updates are applied only to those route segments that do not create a violation. Retrace reapplies the preferred width and clearance requirement to an existing route. And using retrace, you can easily decrease or increase the routed width of a selected set or net by using setting new constraints. So we'll see live demonstration how ActiveRoute works. So basically this is a PCB. We are routing this PCB by using ActiveRoute. Okay, in order to route in the ActiveRoute, we need to select multiple tracks at the same time. For that, you can press and hold Alt key on your keyboard, Alt key, press and hold Alt key and select right to left all the tracks which you want to route. I'm again repeating, press and hold Alt key, select from right to left, and the nets are selected which you want to route. This is a PCB ActiveRoute panel. You can access this ActiveRoute panel from panels PCB ActiveRoute. And here in the PCB ActiveRoute panel, you will get an option tune selected, ActiveRoute, pin swap, gloss result, route guide. Route guide, as I said, route guide, will see what is route guide, how it works. Then layers. Layer only shows signal layer. If you uncheck this, you will get all the layers. If you check signal layer, it will display only the signal layers, top layer and bottom layer. Then some controls, track to track spaces. I have stated track to track as per the design constraints. Okay, so I have selected these traces which I want to route. I am simply clicking on ActiveRoute. We have shortcut for ActiveRoute, Shift plus A. See, the result are these all nets are routed. Okay, and for ActiveRoute you can use Shift plus A. Then I will select, you can select multiple pads, same, press and hold Alt key, drag from right to left. All are selected, all nets are selected. Just click on ActiveRoute. Here you will see the progress of ActiveRoute, glossing and all. See, routing is done in a minute for a multiple tracks. But this is top to top routing. Okay, these connections are starting from top and routed at top only. But if you saw here, if you select all, see, these are connections with top and bottom. These are connections starting from top to bottom. ActiveRoute does not create wires. We need to place wires initially and then we need to route actively. So press and hold Alt key. I'm selecting from right to left. Click on route. So these connections are starting from top and routed to bottom. So from top to bottom or top to inner layer, you can route by using ActiveRoute. Again the same, I am simply selecting the ActiveRoute, and here we need to uncheck onto which route we need to route the PCB. Okay, so this PCB is routed using ActiveRoute. If you want to gloss the result, already we have selected the gloss result. If you have not selected gloss result, select the net which you want to gloss, go to route and gloss selected. Control Alt G is the shortcut for gloss results. So this is glossing. So now, most of the time BGAs are very critical to route. Okay, these are BGA IC which are sometimes very critical to route. In order to route the BGAs, we will use route guide. Okay, here the same. See, I am unchecking all the layers. If you uncheck show signal layer only, see, all signal layer, plane layer is visible. If you checked, only the signal layer is visible. Okay, so these are the layers for this PCB onto which we need to use ActiveRoute. So I am selecting the nets. Again alter. See, I have selected only below section. I am using L1 top layer, L3 signal and L4. I am using only these three layers for this routing, and I am using route guide for this. See, route guide is direction starting from start to towards your end point. You can, I am varying the size by up and down arrow key. By using up and down arrow key, you can vary the size for route guide. Okay, so this is a route guide, and after defining the route guide, I have selected already the layers. Just click on ActiveRoute. Here you will see the progress processing board. Okay, see, conflict is 59 and passes is 3. Completion rate is 4 point. Completion rate is increases and conflicts are decreases. How many passes they have used for this routing, it will show here. What ActiveRoute, it will take this path as a route guide because we have already defined the path in the form of route guide. See, it has follows the path which we defined. This is nothing but route guide. Again the same, we will use, now I am using different 3 layers, below 3 layers, L7 signal layer, L8 signal layer and L10 bottom layer. It will take the layers which you selected. So I am changing and I am again defining the route guide. I am increasing the route guide size up to here. I have defined the route guide and I will use ActiveRoute option. Again you will see the progress here for the ActiveRoute. So basically ActiveRoute is useful for critical routing and multi-layer. If you are using a multiple layer routing, so you can easily use ActiveRoute. It will not take more than 1 minute approximate to route tens of signals. Okay, so it has follows the Same. Now for upper part, I'm changing the layer again. I'm setting route guide. Starting from here, I will increase the size. I will put here. If you don't want to define a route guide, it's not necessary to define a route guide. I will show you routing without route guide, how it will takes place without route guide. Conflicts are decreasing, completion rate is increasing. So this is guided, but I will show you. I am selecting all. Okay, I am checking all the layers. I am enabling all the layers. I am simply clicking on active route. So this is not a guided routing. It will not take any route guide, or it will not follow any path because we haven't defined any path. See, you can see the difference. This is a guided routing. Below one is a guided and upper one is a non-guided routing. You can see the difference between non-guided and guided routing. So this is a route guide. This is a non-guided routing. But you can simply use route guide. If you want to use route guide, in that you can define the layers. Okay, as I said, the fan out option. Okay, so I will show you the routing with fan out. Okay, so this is the IC which is at bottom and which is routed on the top. So I will show you fan out. Go to route, fan out, select the component. Okay, these are some properties. Fan out pad with without nets, fan out outer 2 rows of pad. The first one is fan out pad without nets. First option is, which means enable these options to fan out pad from the component even if they have no net assigned. Okay. The second one is a fan out outer 2 rows of pads. Enable this option to fan out pads from the component including the outer 2 rows which are usually easily routed. Next one is include escape route after fan out completion. Enable this option to add escape routing to each fan out. So I'm not checking fan out pad without net. Okay. See, if you see the pads which are not routed, they are also fan out. Okay. So in order to remove this fan out, I'm simply select the pads, go to panel, go to properties and assign net as a no net for these selected pads. Okay, so I am assigning no net to these pads. Now if I fan out this component, okay, see, you will see the fan out option is completed for those only which assign the nets. Rest for those pad which I have removed the net name are not fan out. So this is fan out with net and fan out without net. If you fan out this component, then also you can route with ActiveRoute. I'm keep opening all the layers. I'm simply selecting ActiveRoute. So they have taken multiple layers. So golden layer is nothing but layer number 3. The green layer is nothing but layer number 7. So it has taken multiple inner layer because I have selected here all the layers. So same, I'm selecting all remaining. These are routed from bottom to top or inner to top. For this also you can route by using route guide, or directly you can click on active route. So routing is done. As you see, starting from here, these are some internal layers which used for routing, because we have fanned out the pads and some are non fanned out. So they are directly routed at the bottom to here top layer. So this is fan out. Okay, if you want to use retrace option, retrace is nothing but you have defined some width and clearance constraints. Okay, if you change that constraint by go to design rules, width, okay, for top layer, yeah, for top layer 0.2 mm to 0.2 mm 2 mm. See, the width is 0.2 mm already. If we 0.2 mm, if we want to retrace this trace, we need to change the design rule from design rules, width, I am changing it to 1 mm for top, apply. Okay, I will select the trace which want to retrace. I have changed the rules from design, go to route and retrace selected. Okay, so if you checked, initially it was routed at 0.2 mm, then I have set some constraint as a 1 mm. Now if you check, this is routed at 1 mm. So you can use the retrace option also by using different constraints. If you have any questions, then please do ask. Thank you for your time and attention.